Hello. Today we're going to be having a look at some of the bounds and error interval questions. We're just going to have a look at some of the simple questions and also some of the more involved questions. I've also got one of the questions from that you were set on MathsWatch, the pack of questions that you're asked to do. Question number 9 in the first week's worth of work. We're going to go through that one together as well, just to make sure that you're happy with it. That was about Joy and her soup. So if we just start with this one, just as a recap and a reminder about how bounds work, what they are, and how we can use some diagrams in order to be able to have an understanding of what these things are. So the first question here, it gives us a garden, the length 14 metres and the width is 10 metres. They've both been rounded to the nearest metre. It would like us first of all to find the upper bound of the length. So here we want to find first of all what is the length. Well, the length is 14 metres, and it tells us here that both of these things have been rounded to the nearest metre. As soon as you get a statement like this, that you've got items here that are rounded to the nearest metre, nearest decimal place, nearest significant figures, etc., that's giving you an indication that the question is about bounds, is about error intervals. It won't always use the word bound, upper bound, lower bound in the question. It won't always use the phrase error interval in the question. Sometimes it might just say things like find the smallest possible value, the largest possible value, and so on. And we'll see that in the next question. So back to this one. We want to find the upper bound for the length. So what we're going to do here is we're going to, for part A, we're going to write down the upper and the lower bound for the length. So the way I do this is I draw myself a small diagram. I find this really helpful, especially if you've got something that's a bit strange in terms of the rounding scheme that you're working to, and that's prevalent in the question about Joy and her soup that you were given on MathsWatch. So again, we'll have a look at that later, and we'll discuss why the idea of drawing a little diagram is quite helpful there. So here we've got our cells. I draw myself a little number line, and I put my value here. We're talking about the length. I'm going to put my value of 14 in the middle. Then what I do is at either end of that line, I write down the value either side of it based on what I've rounded. So here it says I've rounded to the nearest metre. So the next metre along is 15, and the metre before that was 13. Okay, so 14 metres, 15 metres, 13 metres. What I can then do is I can identify my upper bound and my lower bound. In particular, I can identify the error interval by looking at the values that are exactly halfway between these two things. So we've got 14.5 here is my upper bound, and 13.5 here is my lower bound. So here we've got an upper bound of 14.5 metres. Now, one thing that a lot of students often get really confused with here is that they look at it and go, well, 14.5 would actually round up to 15, so surely it must be 14.4 or 14.49. But even if you said it was 14.49, I could think of a number bigger than 14.49 that would still round down. For example, 14.91 or 14.92 and so on. And unless you cap it at the top and say, well, yes, 14.5 would round up, but this is like the ceiling. Anything below 14.5 would round down. This here is my upper bound. Okay, it represents sort of the like a bit of a fence around your error interval. So from the top to the bottom. So part B, it would like the error interval. Now I've mentioned this error interval once or twice. There's a specific way of writing it, and having an understanding of what these two different types of questions are, so the idea of just giving a bound or writing an error interval and what the examiner's looking for, are important. So here I just need to state the number. The upper bound is 14.5. The second one here, the error interval for the width. So the width has been given to 10 metres. So again, I'm going to draw myself a small diagram, a little line with 10 in the middle. Again, it's been rounded to the nearest metre, so at each end I'm going to put my next metre, so 11 metres and 9 metres. And then it's the halfway points that are going to tell me my upper bound, 10.5, and my lower bound, 10.5, lower bound, 9.5. So here it doesn't want the upper bound and lower bound, it wants the error interval. So because it wants the error interval, I need to write it in a certain way. I'm going to write here that my width, let's call it W, is greater than or equal to 9.5. So W is at the bigger end, so W is greater than or equal to 9.5, but it is less than, so W now is at the smaller end. W is less than 10.5. Now this comes back to what we were saying before, that the upper bound here is like the limit. Anything strictly less than that would round down to 10, which is the value that they gave us for the width. It's not saying that 10.5 would round down, it's saying anything less than 10.5 would round down. The last part here, part C, wants the lower bound of the garden's area. So what we need to do for part C is we want to find the lower bound for the garden's area. Now I'm actually just going to grab another piece of paper to do this on. So we've got width, lower bound was 9.5 and the upper bound was 10.5, and then we've got the length. So the lower bound was 13.5 and the upper bound was 14.5. Now it wants the lower bound for the garden's area. So if it wants the lower bound for the garden's area, then you think, well, how do I find the area? Area of a rectangle, area is base multiplied by the height. Well, base multiplied by height here, if I want the smallest value of the garden's area, I want to use the smallest value for the width multiplied by the smallest value for the length. Smallest multiplied by smallest will give me the smallest answer. If I did largest multiplied by largest, it will give me the largest answer. So here I want 9.5 multiplied by 13.5, and I can just type that into my trusty calculator. 13.5, and that will give me 128.25 meters squared. Okay, so let's have a look at a question now that's a little bit more involved. So this is the second question. I'll just move this down. There we go. So here we have got some values given, and we want to find the smallest possible value of t. Now notice here that the question gives us some values and then tells us what they're rounded to. Nowhere in this question though does it ask us about the error interval. No point in this question does it use the word bound, so you've got to be able to identify that this is all about bounds, error intervals, etc., because of the fact that you're told the information and told what they're rounded to. And then you're looking here for like smallest possible values. You're asked about smallest values or largest values. So what we want to do here is, if we're trying to find the smallest possible value of t, that means we want to minimize t. We want to make it as small as we possibly can by choosing values for s, u and a based on our information here in order to make t as small as possible. Now, it looks a lot more complicated than it is. The first step here and the first way to pick up marks is to start finding your upper and your lower bounds for each of these three values that you've got here. You told the value, you told what they're rounded to, so we can use our small diagrams here in order to work out what the bounds are. So let's do s first. So I'm going to put s here, and I'm going to draw myself a little line. In the centre of that I'm going to put 10.1, that's the value of s there, 10.1. And it tells us that this has been done to one decimal place. So I'm going to go one decimal place above that, 10.2. And I'm going to go one decimal place below that, so 10.0 or 10. And then my upper and lower bounds are the halfway points in between these, so 10.05 and 10.15. Okay, let's do u next. So u is 5, and that says the nearest integer. Remember, integer just means whole number. It's just a fancy maths way of saying whole number. So here I'm going to draw myself a line. 5 goes in the middle. The next whole number up is 6, and the whole number down is 4. Halfway between these is going to give me my upper and lower bounds. So my lower bound here is going to be 4.5 and 5.5. And then finally, for my value of a, I'm going to draw myself a line. In the centre of that line is 2.50, that's the value of a, from there, and it tells us that this has been rounded to 3 significant figures. So let's count it in. 1, 2, 3 significant figures. Let's just shuffle out so you can see. So 1, 2, 3 significant figures. So that means if I go one figure up in that column, that's going to be 2.51. If I go one figure down in that column, that's going to be 2.49. So then again, my values in between here are going to be 2.495 and 2.505. So halfway between 2.50, 2.51 is 2.505. Halfway between 2.49 and 2.50 is 2.495. Now, you've got all the values now for the upper and lower bounds of each of the three quantities. What we want to do is we want to choose which ones we're going to use. Now, you'll remember back to the last question, we wanted to find the lower bound for the garden's area, so we used the two smallest values. Here, the common mistake that people make is that they go, right, well, I want to find the smallest possible value, so I'll just use the three smallest values, and that'll surely give me the smallest. But unfortunately, it won't. If we're trying to minimize t, make it as small as possible, what we want to be doing is we want to be getting a really small number on the top and then dividing it by a really big number. Now, if we start think about how that's going to work, if I chose values to make this number on the top as small as possible and then divided it by a number that was as large as possible, I'm going to get a value that's smaller than if I did it the other way around. If I tried to make the number on top really big and divided it by a number that was smaller, then I'm going to get a larger value in that case. So what I want to do is I want to try and make the top as small as I possibly can and then divide it by something as large as I possibly can. So the bottom's easy. We just want to choose the largest value for A. So if we look here, our largest value for A was 2.505. So what I'm going to do is I'm just going to write here equals, I'm going to put my divide sign in, and I'm going to write 2.505 on the bottom, and that's the value of A done. So the largest thing on the bottom, smallest on the top. Now here on the top I've got subtraction. I've got something minus something. In order to make this as small as possible, what values do I have to put in for S and for U? Well, if I put both smallest values in, so I put 10.05 and 4.5 in, I'd get a small value, but there's a way I can get a smaller value, because if I put the smallest value of S in and I take away the largest value of U, that's going to make it even smaller, isn't it? So here I'm going to put 10.05 in and subtract 5.5, and you can see that, can't you? So if I do 10.05, I take 4.5 away from it. If I think 10.05 and I think I'm taking something bigger, 5.5 away from it, that's definitely going to give me something that's smaller. So to make this as small as possible at the top, we've done smallest to take away biggest. That gives us the smallest possible value on the top, and we're dividing it by the largest possible value for A. So again, we're going to reach for our trusty calculator and work that out. So 10.05, take away 5.5, and we're going to divide that by 2.505. So here we get an answer of 1.82, and that's to 3 significant figures. Now, as promised, I'm going to have a look through the question about Joy and her soup from the MathsWatch pack of questions that we gave you to do. If you want to pause it here or stop the video here because you've still got that question to do, it is question number 9 on the MathsWatch pack of work. Feel free to watch through this and maybe get a bit of a start, and then pause it, go and have a go, and come back, check your answer, and so on. So this is what we've got here. So we've got Joy makes 6.5 litres of soup, correct to the nearest half litre. She serves 280 millilitre portions, correct to the nearest 10 millilitres, and 22 people order soup. Does she definitely have enough soup? Now, this is why I always draw myself a small diagram whenever I'm doing these questions, because here the rounding isn't something nice like nearest litre or 1 decimal place or 3 significant figures. It's to the nearest half litre of soup, so you need to be really careful with deciding what your upper bound and lower bound is here for the amount of soup that she's making. So what we're going to do is I'm actually going to write these two values in millilitres, because that's what these two values here are in, and that way all of my units are all the same. So here 500 millilitres is the same as half a litre, and 6,500 millilitres is the same as 6.5 litres, because there's 1,000 millilitres in every litre. Same way there's 1,000 millimetres in every centimetre, 1,000 milligrams in every gram, and so on. Right. So we're going to find out what our upper and lower bound is for how much soup she makes, find out the upper and lower bound for how much she serves, and then think about what we need to work out in order to determine whether she definitely has enough soup. So join mix. Right, let's find our upper bound and lower bound. So we've got 6,500 in the middle, and I want to work out what our things at each end are. Now, it's been rounded to the nearest 500 millilitres, so I'm going to go 500 millilitres up, so that'll put me at 7,000. I'm going to go 500 millilitres down, so it takes me down to 6,000, and then it's the halfway points here that will give me my upper and lower bound. So 6,250, 6,750. Okay, so nearest half litre, 500 millilitres. So I go from my 6,500, I go 500 up, I go 500 down, and it's just the halfway points that give me my upper and lower bounds. Next, this is what she serves. So Joy serves. Let's draw ourselves a nice little line. In the middle there we've got 280, and this is rounded correct to the nearest 10 millilitres. So we want to go 10 millilitres up, 290, 10 millilitres down, 270. So here upper bound 285, here lower bound 275. Now let's just shuffle that up because we've got all the information that we need. It tells us that 22 people order soup. We want to know, does she definitely have enough soup? So what we want to think of is, what's the worst case scenario? In what things would have to happen in order for her to potentially run out of soup? So what could happen is that whilst it's 6,500 rounded to the nearest 500 millilitres, it could turn out that she hasn't made that much soup. Maybe she's actually made the smallest amount of soup, so 6,250. So she's got less soup. That's when she's more likely to not have enough soup. So what we're going to do is we're going to think, right, well, 6,250 is how much soup she might make. And when she's serving it, when she's filling up her ladle with soup and pouring it into some bowls for each person that she serves, she could be being quite generous and putting 285 millilitres of soup in, compared to anything else in between that rounds to 280. Now, let me just correct that there. She couldn't put 285 in, because if she did put 285 in, as we know, that would round up to 290, but anything less than 285. So remember, this here is our upper bound, our top limit. So this is the number that we're going to use, because we can't use anything less than that, like 284, because 284.1 or 284.2 would be bigger than that and still round down. So we are going to use the 285. So 285 is how much she serves. I want to think, well, how many times could she serve 285? How many 285s can I fit into 6,250? Again, let's reach for the calculator. 6,250 divided by 285. That would give me 21.92, etc. So the question is, would she have enough soup to serve 22 people? Well, no, she wouldn't. She would, on the absolute worst day, she'd have just a little bit shy of serving 22 people. So the answer here is not that she definitely would have enough soup. It's that we don't know whether she would definitely have enough soup or not. So when you're writing this question out, your final statement here would be to say that we are unsure as to whether Joy definitely would have enough soup or not. The phrase that they want you to write down on the question here says, Joy may not have enough soup. So your final statement needs to be that, but you need to have working out like this in order to show and show that you've done your work and you get the marks. This is one of those questions in the exam where you can't just say she would have enough soup or wouldn't have enough soup, and just hope that you get the full marks on 50-50 chance of being right or wrong. This here you would need to make sure that you show that you're working in order to get full marks. I hope that's been helpful, and if you've got any questions, then please do either send comments on MathsWatch. If there's a particular question that you're stuck on, you're unsure on it, you can leave comments on that question and I can see those. I have written some comments of my own on some questions that a lot of people are getting incorrect or finding difficult, so please do go back and look at those and have another go. I will continue doing that as we move through, and I'll keep going back and looking at some of these questions in those packs where they match up with the content week by week that I'm putting up on the YouTube channel, and also the worksheets that are on SharePoint. So as I say, hope that's helped, and if you've got any more questions, just drop me a comment or drop me an email.